Hello everyone. Today we are going to discuss the fourth problem of Leetcode Biweekly contest 120, which is the count the number of incremovable Subarrays 2. So the first problem for the contest is count the number of incremovable Subarrays 1, in which the constant is lower, which is solvable in order of n cube. So let's explain the problem statement first. So the problem statement defines the incremovable subarray. What is an incremovable subarray? So we are given an zero index integer array nums, which is containing of positive integers. Now a subarray of nums is called incremovable if after removing the subarray from the nums, the array will become strictly increasing. So let's take the sample 5 3 4 6 7. So if we remove 3 4 from this array, then 5 6 7 will be the rest elements, and that is strictly increasing. So 3 4 is one strictly increasing, 3 4 is one incremovable subarray. Now we have to find the total number of incremovable subarrays of nums. So the order of NQ solution will be like, let's go through all the subarrays and let's read them from the array and check if the rest part of the array is strictly increasing or not, and count accordingly. So that's the order of n cube solution I'm talking about. Now let's jump into the possible observations. So one possible observation here is that, let's say we have some prefix from 0 to I, and we have some prefix j to n, and we are deleting the subarray from I plus 1 to j minus 1. So what could be the possible cases? What could be the must haves for the prefix and the suffix? So the for the prefix and the suffix, the first thing will here will be 0 to I should be increasingly sorted. Similarly, j to n should be increasingly sorted. This should be increasingly sorted. That is two cases. Then the third point here should be ai should be strictly lesser than aj. Okay, that are the three cases we have to always consider when we are removing some subarray from the given array, right? So let's say let's say we how we are solving the problem. So for solving the problem, I am iterating over all these j indexes, and I will try to find the maximum I value here, because this is the fourth observation, you can say. Let's say we have defined that from 0 to I and j to n, this concatenation gives us one possible strictly increasing array. Then we can say that uh, for any k less than I, this 0 to k and j to n, 0 to k plus j to n should give us strictly increasing array. Why is that? Because we have already told that 0 to I is increasingly sorted. That means that ak should be less than ai, ak should be less than ai, and the prefix from 0 to k is already sorted, because from 0 to I is sorted. That means that 0 to k is already sorted. Now ak is less than ai, then we have told that ai is less than aj, then we can say that ak is also less than aj. So the three conditions for 0 to k is already sorted, j to n is sorted, and a k is less than aj. So that means that for any k less than I, we can delete k plus 1 to j minus 1 as well. So if we find for any j, if we find the maximum value of I, then we can say we can delete I plus 1 subarrays, right? We can delete I plus 1 subarrays, because we can delete I plus 1 to j minus 1, we can delete I to j minus 1. Similarly, we can delete 0 to j minus 1. So there could be I plus 1 values here. So total number of incremovable subarrays will be I plus 1 for a particular index j. Okay, I hope you get it. Now if we are iterating over j and we are able to find I, then the problem is sorted, right? The problem is solved. But there is one case we have to handle, where we are deleting some suffix, right? Because when we are iterating over some j, we are considering that this j, from the j, the rest of the subarray, this j to n, will be in our final array after deletion, but we are not considering the suffixes. For considering the suffixes, what we have to do, we have to find the increasing order of prefixes, right? So let's say our increasing prefix is a1 less than a2 less than a3. Now there are 7 elements here, right? So we can delete the rest 4 elements, 4 5 6 7. We can delete 3 4 5 6 7. So let's say 4 5 6 7 are there, so we can delete 4 5 6 7. We can delete 3 4 5 6 7. Similarly, we can delete 2 3 4 5 6 7. Okay, so what is happening here? So it's happening, right? uh, the number of the length of the longest increasing prefix or strictly increasing prefix, let's say that is k, then we can say that there could be k suffixes we can delete. So incremovable suffixes would be k, right? I have already explained here. 4 5 6 7, uh, 3 4 5 6 7, and 2 3 4 5 6 7, right? So there are three values, right? So let's jump into my solution. I will try to explain what I am doing here. So this pre-array will give us nothing but the strictly increasing prefix. So let's take one example. So let's say 1 2 3 2 5 1 6. Then for this array our strictly increasing prefix will be nothing but 1 2 3, right? I hope you get it. Now we are iterating over all the values of j. J, that means our the right pointer of the deletion. uh, we are iterating over all the values of j. Now if it is less than n minus 1 and ai greater than equals to ai plus 1, so let's consider it as j for your understanding, because in my explanation I have told it as j. So let me change it, this all i's as j. Now, if aj greater than equals to aj plus 1, that means our suffix is not strictly increasing, then we are breaking from the array, right? Because we can't make it, right? Let's say we try to build 0 to I and j to n, right? We try to build this subarray. Now, if from j to n the suffix is not strictly increasing, then we can't make it, right? So we are breaking. This is the break condition. Now we are doing some binary search on the prefix array to find the value which is ai less than aj. We are trying to find the value ai which is less than aj in our strictly increasing prefix, right? Now this part is for binary searching. We are trying to find aj, and after that we are decrementing the value of w. Why I am doing that? Because let's say there could be some possible values, right? There could be, let's say our prefix value is 1 2 3, and we are trying to find the index which is lesser than 3. So we will get to 3 and we will decrement the pointer by 1, and then I will get 2, right? I hope you get it. Now here one another thing to observe here is that let me delete some part, right? Now one important thing to observe, that I am saying that let's say our strictly increasing prefix is like that 1 2 3 4 5 6, and we are at some index 4. Okay, then we have to consider that our right pointer should be at here. Okay, sorry, our right pointer should be at this index at 2, right? So we are taking uh, w is minimum of w comma j minus 2, because here instead of taking ith pointer I am taking I minus 1, because I am considering that I to j minus 1 should be deleted. That's why I have taken w to minimum w comma j minus 2. If you are considering it as I, then you can do w comma j minus 1, and we are at the end we are adding answer plus equals to w plus 2. If you take want to take j minus 1, you can do this w plus 1 also, right? That's what I have explained here. We're doing I plus 1, right? uh, and this part is for considering the suffixes, and if the entire array is sorted, then we have to delete that from the case, the suffix deletion, because we can't delete the entire prefix, right? We can't delete the entire array. That is not the case, right? We have to delete some possible subarrays which is less than n. Okay, I hope you, sorry, I think I have not explained this part properly. So if length of pre equals to n, we are deleting -1 here, because let's say our prefix value is 1 2 3 4, but we can't delete an empty suffix here. We can't delete an empty suffix here, so we have to delete -1 if the length of the prefix is equals to n. There could be some doubts in any part of the explanation. You can always write it in the comment section. I will also provide the link of the code in the description box. You can refer that. If you find this video helpful, please like the video and subscribe to my channel. Thank you.